Alright guys, today we're going to discuss another way to solve systems of equations. Remember, we're trying to find a place where two lines intersect, and we're trying to do it without graphing. We've already talked about substitution. Substitution is nice if one of your variables has a coefficient of 1. If you look at these problems here, none of these variables have a coefficient of 1 or negative 1. So substitution sometimes is good, and then other times you might want a different approach. Elimination works, and you could do substitution and or elimination, I'd imagine, on most if not all of these problems. But I want to show you elimination because what you're going to do is not always use elimination, not always use substitution, but based on what you see, decide which one is more efficient or which one makes the most sense. Now, in order for us to understand how to do elimination, we need to understand opposites. And so I got these two examples here, and 6x minus 6x is 0, right? Not 0x, but 0. And negative 3y plus 3y is also 0. You notice how both of those give you 0. See, these are opposites. Same number, same variable, different signs. So that's an opposite. What we're going to be trying today is to make our x's or our y's, not both, make one or the other be the same number but different signs, so it can eliminate itself. Okay, that's the idea of elimination. Now here's the steps. You got to have opposites in one of the variables. If not, make it by multiplying the whole equation by a number. I'll show you that step. Okay, and then you're going to add both equations together, similar to what you see here. Solve for the variable that you have after you add them together, and then you're going to substitute. So there is a little substitution in this. But let's go ahead and do some examples so you can actually get what I'm talking about. We're going to work number 1, where number 1 says 2x minus 4y equals 13, 4x minus 5y equals 8. I'm not going to do substitution because I'm looking at this particular problem and none of these have a coefficient of 1. If I divide everything by 2, like if I solve for x, that's okay. That'll be an even number or an okay number. But 13 divided by 2 is a fraction or a decimal. I don't want any decimals. Same thing down here. If I divide by 4 or negative 5, I'm going to get fractions. So substitution is not going to work. But you don't have to go that far. Just notice none of your variables have a coefficient of 1 or negative 1. There may be times where you can divide everything by one of the coefficients and it goes in evenly. We'll cross that bridge when we get there. Alright, so the next thing is to decide that you're going to do elimination. So I am going to do elimination in this particular problem. And so after we decide we're going to do elimination, then the next thing is to look at number 1. I need opposites either in my x's or my y's. Now, it doesn't matter. Now notice I don't have opposites. Now when I say opposites, I'm not just talking about sign. In this particular lesson, opposites has to be same number, different signs, okay? So I don't have opposites as it pertains to what I just said here. And so what I have to do now is decide if I want to get rid of my x's or my y's. It's up to you. You decide. And you don't have to pick the same thing on every problem. You don't always have to do x's. You don't always have to do y's. My thinking behind this is if I can just multiply one equation, that's great. Could I multiply both equations? Sure. But I'm looking at negative 4, negative 5. I'm looking at 2 and 4, and I'm saying out of 2 and a 4, I can make a 2 become a 4 by multiplying. Now that thought that I just said came from my head. That's something that I understand about numbers. If I'm going to make 4 and 5 be the same number through multiplication, I'm going to have to multiply 4 by something and 5 by something. But I can make 2 and 4 become the same number by just multiplying the 2 by 2. But in this sense, I don't want them to be the same number. I want them to be opposites. So what I'm going to choose to do is multiply this whole equation. Notice where I put my parentheses. This whole equation by negative 2. And so when I multiply that by negative 2, I get, and I'm going to write it underneath, I get negative 4x plus 8y equals negative 26. That's negative 2 times everything in here, which gave me those. Negative 2, and negative 2. Be careful with your signs. Now, I'm no longer looking at this equation. Okay, now it's just these two right here. After you do that, step number 2 says add both equations together. So I'm going to do that. I'm going to combine both of these equations together. Those two cancel out, or they are eliminated. And I have negative 5y plus 8y, which is 3y, and 8 minus 26 is negative 18. Then you divide by both sides by 3, and you get y equals negative 6. Remember, your answer is a point, and so that means that simply my y coordinate is negative 6. Now, I need to figure out what my x coordinate is, and so what I'll do is either go back to this equation, or the original one right here that I multiplied by. Guys, it does not matter. You just pick one. Say I go back to the original without the negative 2 there. So that's 2x minus 4 times what y is, which is negative 6, equals 13. Now I'm going to substitute 2x, or multiply, excuse me, plus 24 equals 13. Two-step equation, subtract 24, 2x equals 11. Not 2, but 5 and 1/2. Okay, so I did leave off my negative, and so that should be negative 5.5, or negative 11 over 2. And that is your answer. Let's continue on looking at number 2 here. Notice that on number 2, again, no 1 as a coefficient, so I'm not going to do substitution. Okay, neither one of my equations are already solved for x or y. So I'm going to look to do elimination. So you have to think about that first. You can't just jump into it, or you can, but it makes a lot more sense to think about what I'm doing first. Since I'm going to do elimination, now I need to decide x or y am I going to eliminate. Me personally, I usually like to deal with the smaller numbers, like 12 and 8 are a little bit bigger than 7 and 5, but again, there's no rhyme or reason. You can pick either one. So if I'm going to look at x again in this particular problem, notice that they already have different signs, so I don't have to worry about that. I just need them to be the same number. Okay? And so when I look at 7x and 5x, I'm thinking, what number can they both be? If you ever have any doubt and you're trying to figure out what number I can multiply them by, you can always take their coefficients and multiply the other by their coefficients. Notice I took the 5 up here and the 7 down here. You say, well, why didn't you make it negative 5? Well, I need them to be opposites. If I bring a negative 5 up here, then this will be negative, and then this will be negative. And I don't want both of them to be negative. I just want one. So you have to actually think about what you're doing and what your outcomes are going to be instead of just putting numbers up there. Now, when I multiply everything by 5 up here, I'm going to get 35x minus 60y equals negative 110, I believe. And then down here, I'm going to get negative 35x plus 56y equals 98. So 5 times all of this up here gave me this line. I'll just draw an arrow so you can see where it came from. And 7 times all of that gave me that line. Again, so you can see where everything came from. Now, when you put everything together, again, those are eliminated. That's the idea of elimination method. You got negative 60y plus 56y. That's negative 4y. And negative 110 equals negative 12. You divide by negative 4 and you get 3. Remember, your answer is a point. So that means the y coordinate is 3. I can find my x coordinate by taking this and substituting here, here, or the two originals. I always use originals because these have been multiplied. The numbers are a little bit bigger, but again, it does not matter. Say if I take this equation, negative 5x plus 8 times 3 equals 14. All I did was just substituted 3 in for y here. That's negative 5x plus 24 equals 14. I'm going to subtract 24, and I'm going to get negative 5x equals negative 10. Divide both sides by negative 5, and x equals 2. So my answer here is 2, 3. Now, I just want to make sure you guys understand what's happening here by picking the numbers that you multiply by. Step number 1 is usually the issue. When I say step number 1, I'm talking about this here. It's the issue that most people have with using elimination. If all else fails and you're having a hard time trying to figure out which numbers to use, you can always invert or flip the coefficients. For example, if I was going to eliminate the y, I would have multiplied down here by 12 and up here by 8. You can always take the numbers there and flip them, and you don't have to sit here and stay on the problem for 5 hours. But the person who takes the time to think about, well, if I can just multiply this one by a number, then you'll save yourself a lot of work. But both people or both students will get to the same answer. So you might want to spend some time trying to understand or practice coming up with this, or ask me questions in class. We are going to come back to this, and we're going to need to do this later as we introduce z. All these equations are x and y, but we're going to introduce x, y, and z. Alrighty. Peace.